Hello everyone, my name is Hải. Welcome to our presentation of subject deterministic model in operation research. This is our group member with Trần Đình Khang, a team leader, and me, Nguyễn Đình Hải, and Phạm Văn Thảo is his teammate. It is a table of content of our group. First one is introduction. Let's get it. In introduction, we separate it into three parts. First one is background of the subject. We have three questions. First one, what is operation research? Operation research is a problem-solving and decision-making analytical method that is effective in the management of organizations. The second question is why we need operation research. Among us in this century, decisions are frequently break up by facts. Today, we have more data than at any other time in history. The growth of the data science discipline, which combines data, computer science, and basic mathematical concepts, has resulted from the use of data to aid decision making. And the third is the importance of operation research. The purpose of operation research is to achieve the best performance under the given circumstance. It involves the optimization of the problem by comparing and narrowing down the potential options. Next part, we continue to the problem. This is problem 4 we choose to solve. And the next part is identification of the problem. Our goal in this project is to apply the concept of operation research to develop a mathematics linear programming model and solve it to determine how many plans of each kind the coffee shop should plan to create every week to maximize profit based on the data supplied by the coffee shop. Next is mathematical model. I will let my friend continue our presentation.
Hello, my name is Thảo, and we will continue to the mathematical models. First, we will need to set a parameter. A parameter is a kind of variable that affects the output or behavior of the mathematical object, but is assumed to be constant. Parameter and variable are closely connected, and the distinction is sometimes basically a question of perspective. In this problem, our parameter is the selling price, mixed requirement cost, and available kilogram per week. In selling price, this is $6.5 per kilogram for special, 5.25 for dark, and 3.75 for regular. The milk requirement is at least 40% of Colombian and at least 30% of mocha for special, at least 60% of Brazilian, and no more than 10% of milk for dark, and no more than 60% of milk, at least 30% of Brazilian for regular. The cost is $2 per kilogram for Brazilian, $2.75 per kilogram for mocha, $2.9 per kilogram for Colombian, and $1.7 per kilogram for milk. After having the parameter, we will set the decision variable. The decision variable are unknown and controllable parameter of the system, which finding their value is the purpose of the problem-solving effort. The value of decision value determines the system objective function value, and in our problem, we denote that S, D, and R stand for special, dark, and regular black coffee. Also, we let B, M, C, and L denote for Brazilian, mocha, Colombian, and milk coffee. So we will set this example. XBS is the amount Brazilian used in special. XBD is the amount Brazilian used in dark. and XBR is the amount Brazilian use in regular. And similarly for the rest, and we will have these two tables. After having the parameter and decision variable, we will move to create the objective function. Our objective function is maximize the profit of Z. We are showing you in the slide. And we will find the constraint. First, we consider the variable, the available amount of each type of coffee at a coffee shop. The shop has 110 pounds of Brazilian, 70 pounds of mocha, 80 pounds of Colombian, and 150 pounds of real coffee available per week. From that, we can have 4 constraints, 1, 2, 3, and 4. Similarly, for the rest 6 constraints, and after having the objective function in all the constraints, we will move to solve the problem. We open the Excel and first make this table, set all the variables equal to 0. Second, we add in the constraint for special, dark and regular. For example, T9 larger or equal than 30% multiplied with T11, which means T9 is the amount Colombian used in special. Larger or equal than 40% of T11 is all the amount of special. Similarly for the rest constraint, and we will add the equal in the bounded region in Excel. Last, we set the parameter in solver. We set the objective function in F14, which is an objective function we have shown you previously. We choose the maximize profit. The variable cell from G7 to I10, and subjective constraint is as follows. We choose the select, LP, click solve, and we will get a final result. The final result is $1,296 per week. And we can see that from the table, the profit can be maximized when XBS equal to 0, means the amount Brazilian used in special is 0 kilogram. XBD is 54.8, means the amount of Brazilian used in that is 54.8 kilogram. XBR is 55.2, means the amount of Brazilian used in regular is 55.2 kilogram. And similarly for the rest of the constraint. And that's all. That is how we solve the problem by Excel. And next, we will move to Lingo. And Chen Khan will show you how to solve the problem by Lingo.
My name is John Skans. Before going to solving the problem, I will give you some information about Lingo. Lingo software is a programming software that makes it easier and faster to develop and solve linear and non-linear integer optimization models. Each modeling language allows users to articulate their challenges in a straightforward mathematical manner. Lingo is a tool for solving linear optimization problems. It also solves certain kinds of vertically constrained problems. We go to the next slide. You can see here on the screen is exactly what we put everything into the Lingo screen. The first one is the model. From the next is the constraint. We have 11 constraints. Then we end. Now we can get the result from the first table. We can see the objective value is 1,296. It's the same number of compared to the Excel solver of tell variable with 11 constraints. The next table, we can go more detail in the next part. Now we go to the sensitive analysis. First of all, sensitive analysis have to study how the optimal solution will change with changes in the input coefficient. In the slack or surplus, it indicates how near you are to satisfying constraints and equality unless or equal to limitations. This amount is commonly referred to as slack. This number is known as the surplus in the greater than or equal to the limitation. And another thing is dual price. Dual price is the amount that the objective should improve at the right hand side of the threshold of the contrast is increased by 1 unit. In a maximization problem, improvements mean that objective value would increase. Finally, it reduces cost. It can count the opportunity cost. It can be interfered at the rate at which the value of objective functions will deteriorate for each unit change in the optimized value of the decision value with on other data. Now we go into the conclusion.
I'm Hai and I will continue our presentation. We can see this is the result of our problem. And when compared to Lingo software and Excel solver for programming problems, you may directly confine the decision variables using some efficient built-in method, making issue difficulties simpler to solve. The problem may also solve linear programming at the same time, making it more intensively used. Both Lingo and Excel solvers give us a similar answer of 1296, which is the quantity of each mix that should be prepared each week in order to maximize profit. The next is application. In reality, linear programming is commonly utilized, particularly for assessing supply chain process in industrial companies. Linear programming will assist these businesses in selecting the optimum roles, allow them to save money and time while still completing all of their order and without exceeding each other's delivery schedule. Our crew has investigated and assessed the best solution to the situation. In general, linear programming has a wide range of partial application in real life. Optimization is important, particularly in the production and supply chain, since it allows other operations to run more smoothly and effectively, which may have a significant impact on companies' or business future development. In this project, we use a mathematical linear programming model to calculate how many plans of each kind the coffee shop should plan to generate each week in order to maximize profit. Furthermore, it can apply for logistics problems such as maximize or minimize profit, define capacity, optimize the distance of several warehouses. And that's all. Thank you for participating.